Hey everyone, welcome back to, what is this, episode 6 of putting a motorcycle engine in an old British car. Now, last episode you saw me make this guy out of this guy, and that adapts that CV axle to the transmission of the motorcycle. And you also saw me say that this was the drive shaft for the MGB. And I said that because the previous owner who I bought the car from said that. And I didn't do any research and I didn't check it, and I just assumed he knew what he was talking about. Well, turns out that's a drive shaft out of a Nissan 240SX with a KA24 that he had put in the car. And I didn't learn that until after I went ahead and started cutting it up to make my own drive shaft. So sorry Nissan people, I would have had a nice drive shaft somebody could have, but not anymore. So I hopped on eBay and I ordered a new to me MGB drive shaft. So let's open this thing up and see what we got. Oh wow, look at this cute little thing. It's tiny. I'm going to finish unwrapping it and I'm going to throw it in the car along with the new front half of the drive shaft and hope that they're going to mate up within an inch or two of each other. I don't know. Fingers crossed. Let's see what happens. Oh, and check this out. I'm finally doing something smart. I'm measuring this flange before I put it in the car so I don't have to do it upside down on my back. Great success. I am currently 3D printing this guy, which looks a lot like a pipe union or something, but that's a drive shaft adapter that will adapt. This is the small side, that's the MG, to the 4x100, which is the Volkswagen hub. Basically I just want to bolt them together and figure out if the length or the height here is the correct dimension, so I can fine tune that. I've got this bulkhead. I've got these pieces at the laser being cut right now. These here. So I went ahead and 3D printed these guys, which the bolts will thread into because these holes are awfully big. But check this out. This is satisfying. But that's what the bolts will thread into for now until I make something more permanent. But that's kind of neat. Those are two-piece. So we'll have these little side wings bolted in shortly, and we can see what this piece is going to look like, where it's going to live. So hopefully this print will continue to work and it's not going to peel up from the bed or anything. It's estimating it's going to take 5 hours and 45 minutes, which means it'll take about 7 hours because that's never accurate. We'll see what happens. Almost done. 71%. Well, the print worked, but I think I goofed up a little bit. I made these holes 10mm and they're supposed to be 12mm. You can see this is tapped. So I might try to drill them out and risk the entire part exploding because this type of plastic I'm using is cheap and brittle. Or I might just use smaller hardware because it doesn't really matter. This is obviously not going to be under any pressure or any stress because I'm not going to actually use it. It's just a mock-up deal. Also, there's a 1/4-inch gap here. I got to put a 1/4-inch spacer in there for something I might be doing in the future. Hint, hint. But for now, I'm going to print little spacers to go in between it. You guys want to see something ironic? I'm on the way to machine this carrier bearing for the MG, and my Volvo's carrier bearing decides to give out. It may not be the carrier bearing, it may be the rubber mount. I think it's the rubber mount for the carrier bearing, but we'll see if we can limp this thing the rest of the way. limped it on and made it. Now making it home may be a different story. We'll see. Well, you can see I have not cleaned up the mess from the last part I made here. And I do not own a boring head for the mill. So you may wonder, how am I going to put a round bore in this squarish part? Well, it would be easy if I had a 4-jaw chuck for this lathe, but that's something else I don't have. So I'm going to try a, we'll say, controversial method. We'll see how it works. I'll talk you through the process. Step 1 is we drill and tap a hole in the center of the part, or slightly off center. It's where you want the center of your bore to be. And you put a bolt in the chuck and thread it in, which I haven't got it tapped quite deep enough. But that'll be our first stop work holding solution. So we got her fixed into place here, and this is going to be what you call an interrupted cut, because it's only going to be cutting on these corners at first. These two will touch, and then since the hole's slightly off center, there'll be a gap there for a little bit until the diameter gets down small enough to catch on those. But you can see it's only going to be hitting in those 4 points for a while, and there's going to be a lot of hammering forces on this insert. So I've shortened it up as much as possible. All I have to do is cut a small little register on this, and the diameter has to be small enough to where the 3-jaw chuck can touch 3 of these newly machined surfaces at once. And then the part itself will ride on center to the bore, and then I can cut the center out and actually start doing the bore. This will be a fun, nice interrupted cut though with this. It won't be sketchy at all. Went over. 2,000. Whoops. We'll be all right. Now this diameter I cut isn't important what the diameter actually is. I just need enough of a register for the 3 jaws to grab onto. So we're going to try that out and see if they all 3 land where they need to. There it is, just enough register for all 3 to grab. And I think it's going to work. Not the best method for doing this, but it's the only method I have that'll work. So I was using the hole saw to cut the center slug out, just like in the last video. I wasn't going to show it because it's the same as the last video, but I went a little too aggressive at the very end and ripped the threads out of the hole saw there. So still sharp, but I can't use it anymore. So now I'm trying to bore it without a boring bar. This sucks. Yeah, this isn't working, so I've decided to try this again, except I've double nutted it. So you can see there's a nut on the inside. The only problem with that is I just barely had enough depth of cut to get through that piece as it was, and now I've reduced that by 3/8 of an inch or so. So I can't do it in the lathe, but I can take the part out and flip it upside down, put it in the drill press, and finish getting that slug out. So Not ideal again, but ought to work. Got it. Now, back to the lathe. I want this face to protrude very slightly, this outer race here, because there's going to be a cap that bolts on to lock it into place. I didn't really want to press fit because I don't want to have to press this into the block and the hub into this. This is still very hot, so as it cools off, that fit will get a little tighter, but right now it's about a thou clearance. Got the turning work done on this part. And now that it has cooled off, it is a light press. I can't even do it by hand. Just kind of what I wanted. Now looking at this hub, I wish I had gotten maybe a Mark II hub. If this bore is the same and the splines are the same, I'm not sure. Because it has all these extra holes in it for these three here, for the ABS tone ring, and I want to make this diameter as small as possible for the speed it's going to be turning. I want to get rid of any extra mass I can, especially if it's far from center. So I want to turn this down to say 4-inch, but it's got all these extra holes in it. I don't like that. This is a Mark II Golf axle, hub, knuckle, all that stuff that I have modified a long time ago, and you can see it doesn't have any of the extra holes in it. It has one little extra down here for the rotor, but that's it. So I would have been better off buying one of these, but I wasn't sure if all the other dimensions were the same. Still not sure. I'm not going to pull this one off and check because I don't want to mess with it, but yep, we'll see what happens. I'm going to turn down the hub of this OD this hub. The chips are coming off hot, gold, perfect. Check that surface finish out. Before we get down into those bolt holes, it becomes an interrupted cut. It's not going to look that good. And take that back. I did manage a pretty good surface finish, even with the interrupted cut. Now those goofy parts, sharp as can be, and probably out of balance now, but we'll see. Not ideal. Story of my life. Man, heaven forbid anything get tangled up in this while it's spinning fast. It's going to be a bad day for whatever gets in there. Slightly lighter now, and much goofier looking. I don't like the way it looks, but I'm going to use it anyway. On a budget. Went ahead and decided to take some weight out of the back side of this hub because it's not going to see nearly the forces it would in its original application, you know, holding the weight of the car up with all the cornering forces and stuff like that. So why not save a little extra weight? Now that I've got the carrier bearing and drive shaft supported very precariously on this 2x4 and jack stand, I can basically slide the entire carrier bearing forwards and then backwards. And that's using the plunge here in the slip yoke and the plunge in the CV up front. But what I need to do is measure this distance here and then figure out the drive shaft length the rear axle is at full droop right now. So when the axle goes up at ride height, it actually gets a little bit longer. So if I measure this length right here, say it's 2 inches, I can subtract safely an inch from this spacer here, and I will still have enough slip yoke to be safe here and up there. So this 3D printed part is basically just to let me measure that distance right there. Yep, we're jammed all the way forward as much as we can go. So I'm going to throw a tape measure on this real quick and see what it looks like. Looks like I've got around 1 3/8 inches. So I think I can safely make this adapter about 1 inch shorter than it is. I want to make it as small as possible for lots of reasons, but man, this car is gross underneath. I don't know, 50 years of leaking oil and road grime caked on. I'm going to have a fun time welding a new cross member in right here. I'm not looking forward to that. Got to do it though. We almost have a complete driveline. We'll have to make that plastic piece out of aluminum, make a mount for the carrier bearing that'll mount to the cross member that's not there yet. And then we got to get the engine running. So, should be a good time. Oh yeah, we'll check out the big aluminum piece up front.